So I did a video recently on a Electrofusion unit for use for melting pipes together and joining pipes. I've just been given another one to look at. Apparently this one's not working either. So if you haven't seen the other video and you're interested in Electrofusion and what I went through to figure that one out, then go and check that video out. I might link it down below or something in the description, I don't know, maybe. Anyway, let's have a look at this one. The plug's looking a bit worse for wear for a start. It's not very straight, is it? These are used outside to, join pipes in the ground. So it's not necessarily clean, a bit muddy and stuff. Anyway, let's have a look. So it's a bit different to the other one. It's a lower power version, and it's also really tangled up. So you can see it's a handheld version instead. And it's got some indicators on here. Apparently what's doing, it's showing this error here, connect fitting. It's not registering as a fitting connected up, which says to me it's probably a broken wire in here. Most likely. We'll have a look. Let's plug this thing in. I'll straighten his pins up, then I'll plug it in and we'll see what we get. I've plugged it in over here so I can use my variac here and adjust voltages and stuff like that in case it matters, but there's no display on it so I don't really know what I'm going to be looking for in this. It's not as advanced as the other unit. So it's powered up. Getting 240 odd volts on there. It's dropped down slightly. Yeah, 230. So that's currently showing a green light and this message because there's no connected fitting. So that's his fitting here. So let's plug this in. That's a really loose fit actually. That does not go on very well. Doesn't feel like it's engaging at all actually. That doesn't feel like it's going in at all. I can feel this one engaging slightly. I mean, could it just be that these connectors have opened up a little bit? Could it be that? Still nothing showing on display, so let's just try and fall it. Alright, so I've got my meter here. I'll just try 20 ohms, just try 10 ohms, and I'm just trying to see if anything will actually trigger this to recognise it's plugged in. Unfortunately you can't really see it well. There you go. Alright, so it's not recognising anything, so it's not like there's a bad connection here, though I don't think the connections are very good. There's definitely nothing going on here. Changing the ranges isn't doing anything. It's not recognising there's a coil connected to it. So obviously it checks for resistance of the coil, and well, there isn't one. So my suspicion here is that there's a problem with probably one of the connectors in here, possibly. Or it could even be a break. I mean, it gets pulled around a lot up here, so it could be a break up here in the cable. These are silicon leads, so high quality leads, so have to be for this kind of job. Bit of an interesting branching thing here. It's like it's over moulded, I'm not sure. Anyway, so something's wrong. So what I need to do is pull it apart, measure the leads themselves, see if there's any problems in either of those leads, and see if we can get it from there. But I don't like the connections on these. This don't seem very good at all. So if you didn't catch my previous video on these Electrofusion units, I should explain a bit more about what they do and how they work. So what they do is they put a high voltage and reasonable current, and they melt the coil inside this connector here. So this is a joiner for two pipes. They stick two pipes in here end to end, and they have to be prepared and scraped off and stuff, so it's got a nice fresh surface. Otherwise apparently the oxygen on the surface can actually affect the welding. And you see there's a little stop in here the pipe goes up to, and this heats up that winding there, just a 20 ohm heating element basically, and that heats up, melts it all together, and that's what fuses it together. So that's why it's called Electrofusion. Anyway, let's get this thing apart. I've turned the power off and unplugged it. Let's find out what's inside here. Should be pretty easy to measure it, hopefully. I really do think it's going to be a broken wire, but then I'm probably going to get proved wrong because I'm so confident that is a broken wire. Right, that's what screws out. Are they captive or not? No, not captive screws. Okay. 5. Last one. Come on, pop out. Right. So it screws out. Let's have a look at this. It's got a rubber membrane seal around there. It's got to be careful not to damage that. See here, it's kind of half stuck down. There we go. This is falling off, it's fine. So how does this come apart? It folds over this way, it looks like. Unplug this. Right, so here's the leads coming down here. So there's also a relay inside there, so that's also possible the relay is bad, but they do fail from arcing. Let's have a look around, see if we can see any problems first. Let's have a look inside, let's actually have a close look. So here goes the inside, so what's that, is that like a triac or something? Can't see the numbers on that. Can't quite get the light on it right to read it. Yeah, anyway, it's probably a triac or something. So also a couple of here, obviously some switch mode supply stuff, relay over here. Got a header which is used for calibration. A couple of other sockets here, I'm not quite sure what they're for. Well, this one goes over here to the start button. Let's combine PL5, PL6, don't know what it does. CTVE. Calderval technology. Okay. Calderval, is it? Maybe it could be Calderval. So some other chip up here, whatever that is. That's a 12C508A. Don't recognise it. Probably some kind of microprocessor. This looks like it's got another transformer under here and some capacitors and stuff like that. I was checking for bulges, they look okay. There's another device on the side of there. What's that? See what that is? KA7906, is that? Yeah, KA7906. So it's a negative 6 volt voltage regulator. Well, there's not much to go wrong in here really. I mean, obviously this chip over here is going to be the controller. That's the microprocessor most likely, unless there's something on the back of the board. So there is stuff on the back of this board. It's likely to be that it's the microcontroller. It's a pretty simple system, so it's probably that. And what's this one here? That's a TS7806. There's a positive voltage regulator, 6 volt regulator. And there's a diode bridge up there. Okay. Well, let's test these cables. Yeah, can't see what I'm talking about. There we go. Let's test these cables here. Check for continuity, and we'll see what we find. See if it's a cable problem or if it's something a bit more sinister. Let's do sounder. Stick a probe in there. Nothing on that one. Nothing on that one. Okay. Check the next one. That was working. Okay, so yeah, we've got a broken cable. Nothing there. That one's working. So this one has to be this one over here. Yep, dead. Broken cable. So this one here has got a problem somewhere. So let's see if I can figure out a way of probing into this nicely and trying to find out exactly what the break is. Well, I've got this kind of jacked up so it'll work. I've got the sharp probe in here. I've got my other probe plugged into the connector here, so it's actually making a nice connection. Let's try and find where the break is. There has to be a break. Now this is what I'm suspecting is over here first. Seems maybe not there. Okay, let's try this end. Here we go. This end. I'm pushing this connector here. So it's probably been pulled. I can actually see this stretching. I can see the silicon stretching. See that? Getting fatter and thinner? Right there. There's the break. See that? Right there. Now the trouble with this, that means I've got to try and figure out how to get this connector apart. So obviously this is like a strain release, but it's not working that well. It's like heat, just a couple of layers of heat shrink basically. Very stiff. But what looks like here is a thread. So I think that screws in. But I'm not quite sure how that attaches to this and how you actually do the attachment. I'm not sure about the angle attachment, how that's going to work. Maybe it needs to be screwed in more, or I don't know. This has got some movement in it. So that might be a clue. Does that unscrew? Oh, this unscrews. Here we go. Right, this is how we do it. Okay, so here's the pin. And this cable here has obviously got to be, it's probably held in place as well, so I'm putting up to slit this off, try and relieve the cable so it's not being pinched, and pull it through and cut it off and put some new on. So I probably need to find out exactly where the break is in here. I could probably just pull it and it'll snap where it is. So let's get this fed out. I'm going to have to slot this, I think. Don't think I can slide that off. Pretty sure I can't. I'll try anyway. Give it a go. Well, I couldn't slide that, so I had to cut it off. So here we go. There's another bit of heat shrink in here. A bit more silicon. So that's probably like the actual original strain relief. I'm guessing that's the original strain relief, and that's been added on by someone at some point. I'm guessing, or maybe I did do it that way for waterproofing. So I'm hoping I can move this around enough to actually get this out. Yeah, that's moving. Yeah, that is definitely moving. So I'll probably fiddle with that and try and pull this through. It's going to be a bit fiddly, but I reckon it's going to be doable. I'll just try to slide this silicon here back. And what I've done is I've got some silicone grease, silicone grease, a little bit of that, slipped it underneath that sleeve, and I'm now able to slide it back. There we go. So in here somewhere is the brake, and that is now moving around. There's actually a crack in this. Interesting. Alright. So let's try and pull this through. So this is a bit of a interesting way of doing it, but anyway, at least it's fixable. That looks pretty good. So let's slide some more through, can I? Yep, excellent. So somewhere in here is the brake. In this section here somewhere. Can't feel it. But there's definitely a brake in there somewhere. Is that it? Yeah, there we go, right there. There it is. Didn't have enough pull through. So there's a brake there. So run my thumbnail on it. Try and get close so you can see what I'm doing. Just trying to show you a way of identifying where the brakes are. So you put it up, then there you go, my thumb's dug in there. So it's sliding along, and then here it's dug in. And you also stretch it and you can see it's getting thin. See that thin spot? That's where the brake is as well. I can feel it. I can feel a notch there. So if I cut it right here, that's where it's gone. So let's strip this off and actually have a look and see what's actually looking like in there. So yeah, that is looking like it's got hot right there. But you can see on the end of here maybe it's looking burnt. See that? It doesn't look right. So if I trim a bit more of this off, that looks clean. Right? So that's clean. That's burnt because that's right where the brake was. So now we've definitely got some decent copper here. So we can strip this off, reattach it to this, and put it back together, and that should then work. It's going to use this because it's silicone. It's going to be easy to break off. There we go. Right. Let's solder this up. So what I'm going to do is I'm just going to put some solder on this, get it ready, and I'm going to put it back through, put the heat shrink on before I forget about it, because that's almost inevitable. And I don't think that's original anyway. I think someone's added it on, but it's probably been done for a reason, so I'm just going to do the same thing. It does make sense to have it on there. Yeah, a bit of solder on there to bind it together. I'm actually surprised by the thickness of the wire in this. It's actually very thin wire. I would have expected them to be a bit heavier than this, considering the currents are involved. They're probably only about 1 millimetre or something. I would have thought it'd be more like 2 or 1.5 or something like that. They're a bit small. Alright, let's get some of this. Try and help prevent it from going bad in the future. Right. So all we've really got to do is, well, also need to make sure it's going to go over. Yeah, that'd be good. I don't think it'll shrink down enough, but it'll certainly give some kind of protection, I suppose. So now I've got to get this off here and solder that one on. My iron might struggle with this because it's a bit of a small tip for this particular job. We'll see if we can do it. Might have to change tip. It's looking like I'm going to have to change tip. It's kind of starting to go. Yeah, it is going. Might be right. There we go. That's off. Let's get the new one on. Okay, that's solid. That's that done. So in theory, if I plug all that into this thing here now, it should actually give me a reading saying it's okay. Once it's cooled down, I'll put it back together and try it before I heat shrink it. Right, it's cooled down enough now. I've started reassembling it. I'm just not sure if this has opened up a bit. That looks a bit open. I think this is actually split open slightly. Just trying to measure that. Yeah, it definitely gets bigger as it goes out. So I think that's actually stretched slightly. So I might just give that a little bit of a squeeze just to improve that very slightly, improve the connection. Because it did seem awfully loose when I tried it on that other fitting. Although it might not be exactly the right fitting for this particular unit, so just give it a little bit of tighten up. Just a little bit. Check it again. Yep, that feels better. That feels even then all the way down now. That's good. Right. Screw that back in. Right, let's power this up again. I'll just pop the case back together and we'll see if it works. Right, let's bedded this seal back in again, or trying to. It's popped out again. Popping out as I'll start recording, of course. Just to make sure it's not folded over and like that. Try and get it straight in so it's in the groove properly, so it's not going to leak. Has to be watertight after all. That's right. Get the cover back on again before it pops off. What's holding it up? These fittings here. It's kind of a bit fiddly to get back together. Make sure these wires aren't tucked in places they're not supposed to be, that kind of thing. It's definitely hanging up over here. This is going to be a bit fiddly. Well, I've got 2 screws in, that holds the case together at least, and we'll hook it up and we'll see what we get. Stick it on here. That actually feels a bit better. That feels like it's grabbing slightly. Yeah, where's the other one? Yeah, it still feels bad. Let's see if I can close this one up as well. Yeah, that's opened up a bit too. So let's fix this one as well. Bad connections on these, probably not a good thing. That's better. That's a nice... That's how it's supposed to feel. I think this one needs a bit more. This must be a bit of an old unit or something, because it definitely benefits from being closed up a bit. Should be a nice solid connection, otherwise it won't work properly. These will get hot. That's better. That's how it's supposed to be. Okay, right. Let's plug this back in, power it up. We'll see if it registers having the coil plugged into it. Let's see what happens. Hopefully we get a different kind of indicator light. There we go. It's ready to go. Excellent. So that'll probably work. So let's shove this over the back of the bench and I shall push start, and I guess I'll have to turn the power off or something. That's on, that's off. Okay. Did a check first that it was right. Heard it come on, it buzzed. Right. I just want to see if there's any heat. Yep, that's working. There's definitely heating. So that's good, that's working. That's back to working condition again. Make sure you subscribe, click the bell icon, give us a thumbs up if you like the video. Check out the other one, which is down in the description probably. Catch you later. So I did a video not long ago on a Electrofusion unit. That's a bad start.